insulating chamber at life potential. The insulating oil is available only in interrupting chamber. The features of designing minimum oil circuit breaker is to reduce requirement of the oil, and hence these breakers are called minimum oil circuit breaker. The next is bulk oil circuit breaker. Now in bulk oil circuit breaker, see, this is the view of a bulk oil circuit breaker. So see, there are two type of contacts. One is fixed contact and second is the moving contact. Now it is filled with oil, transformer oil. Now when the current carrying contacts in the oil are separated, an arc is established in between the separating contacts. So see, when this moving contact gets separate, arc is established between the two contacts. Now this arc will produce rapidly growing gas bubbles around the arc. So as the moving contact move away from the fixed contact, the length of the arc is increased. As a result, the resistance of the arc increases. So the increased resistance causes lowering the temperature and hence reducing the formation of gases surround the arc. So therefore, the arc quenching in bulk oil circuit breaker takes place when the electric current passes through zero crossing. Now next is minimum oil circuit breaker. So this is the view of a MOCB, cross blast MOCB. So first of all, remember that in MOCB, oil is only used for extinguish the arc, and to provide the insulation between the live parts, we have a insulation chamber. So as the volume of the oil in the BOCB is huge, the chances of fire hazard in bulk oil circuit breaker are more. So for avoiding the unwanted fire hazard in the system, one important development in the design of oil circuit breaker is MOCB, in which a less oil is used as compared to bulk oil circuit breaker. So in this type of circuit breaker, the arc interrupting device is enclosed in a tank of insulating material, which as a whole is at life potential of system. So this chamber is called arcing chamber or interrupting pot. The gas pressure developed in this arcing chamber depends upon the current to be interrupted. Higher the current to be interrupted causes larger the gas pressure developed inside the chamber, hence better the arc quenching. But this put a limit on the design of the arc chamber for mechanical stresses. Now with the use of better insulating materials for the arcing chambers such as glass fiber, reinforced synthetic resin, etc., the minimum oil circuit breaker are able to meet easily the increased fault levels of the system. Now see working principle of minimum oil circuit breaker. Now see, in the first diagram, the moving contact, now this is the fixed contact, this is the moving contact. Now see, in this diagram, the moving contact has just been separated and arc is initiated in the minimum oil circuit breaker. Now see, in the first diagram, both the contacts are closed, that is in the normal condition. Now whenever there is a fault, this moving contact gets separate from the fixed contact. Now as the moving contact gets separate, arc is established between the two contacts. So the ionized gas around the arc sweeps away through upper vent and cold oil. So this is the arc. Now in next diagram, here this is a ionized gas. Now the ionized gas around the arc sweeps away through upper vent. Now this is the upper vent, and cold oil enters into the arcing chamber through the lower vent. So this ionized gas get escape from this through the upper vent, and similarly the oil from the lower chamber enters to this pot through the lower vent. The lower vent in axial direction as soon as the moving contact tip crosses the lower vent opening. And the final arc quenching in the minimum oil circuit breaker occurs. So this oil will provide the cooling property for this arc. So by this way, the cold oil occupies the gap between the fixed contact and the moving contact, and the minimum oil circuit breaker finally comes into the open position. So in this way the arc is now extinguished. Now this is the final open position of the minimum oil circuit breaker. Now advantage: the action of the oil as a insulator, the good cooling properties of the gas is formed, absorption of the arc energy in decomposing the oil. Disadvantage: it is easily inflammable, it may form an explosive mixture with air, it requires maintenance. Now again SF6 circuit breaker. Now the difference between these two, oil and oilless, is that here the medium is used SF6 rather than oil. Now this SF6 is used here to extinguish the arc. Now rest of the operation remains the same. Again there is a fixed contact and moving contact. Whenever there is a fault in the system, the moving contacts get separate from the fixed contact. Therefore arc gets established between these two contacts. Now after this, SF6 gas is allowed to pass over this arc, now which will provide the cooling effect. Now this arc SF6 gas have a electron affinity property, that is it loves to take electrons. So it will consume the electrons from the arc. Therefore in this way the arc gets extinguished. Now in this way the arc, now this is the again the open position of SF6 circuit breaker. Now SF6 is a heavily largely inert gas and has superior dielectric and arc quenching properties as compared to air and oil. Most SF6 switchgear operates at a pressure of about 5 to 6 bars. It possesses very good arc quenching as well as insulating properties. It is non-inflammable, non-poisonous and odorless gas. Advantages and disadvantages: the arcing time is very small, therefore it reduces the contact erosion, current chopping can be minimized, no reduction of dielectric strength of gas, it is compact in size but it is little bit suffocating in nature. The next is air blast. Now here the medium used for extinguish the arc is air. Now simply again the same principle. Now when the moving contacts get separate from the fixed contact, arc is established between these two contacts, and then this air is made to blow over the arc. So in this way the arc gets extinguished. again in this type of circuit breaker we are using splitters. Now when the arc is blown over the air is blown over this arc is separated by these splitters. So this will increase the resistance of the arc and therefore decreases the current. So in this way the arc gets eliminated. The next is vacuum circuit breaker. Now here we use a vacuum for the extinguishing of the arc, now becoming very popular for voltages up to about 15 kV. It is used for maintaining the arc. For maintaining the arc, the pressure should be low, but as the contacts separate, higher vapor pressure is developed and hence the arc cannot be established. Now here the pressure should be maintained in the range of 10 raised to power minus 4 to 10 raised to power minus 6 torr, and it is basically maintenance free. Now next is isolator. Now isolator is a kind of disconnecting switch. It always operates under no load condition. It does not have any specified current breaking capacity or current making capacity. Isolator is not even used for breaking load currents. So isolators are used in addition to the circuit breakers and are provided on each side of every circuit breaker to provide isolation and enable maintenance. So remember, isolator always operate at no load, but the circuit breaker can operate at no load, on load and even at faulty condition. Now isolator, while opening a circuit, the circuit breaker is opened first, then isolator, but while closing the circuit, the isolator is closed first and then circuit breaker. Isolators are necessary on supply side of the circuit breaker in order to ensure isolation of the circuit breaker from live parts for the purpose of maintenance. Automatic switching of isolator is preferred. Isolators used in power system are generally 3-pole isolators. So let us compare first switch, comparison between a switch, isolator and circuit breaker. Now switch operates on no load and full load, whereas the isolator only operates at no load, but the circuit breaker can operate on no load, full load and under abnormal condition. Switch can be operated manually. Isolator can be operated manually as well as automatically. Similarly, the circuit breaker can be operated manually as well as automatically.